In this lesson, we're going to look at the integration of sine and cos. And because we know integration is the reverse process of differentiation, then it's easy to work this out. When we differentiated the sine, we get cos. So when we integrate cos, we get back to sine. Always when we integrate, unless we're working out an area under a curve or between two functions, we need to remember to add c. And when we differentiated cos, we got negative sine, so which means if they integrate sine, you get negative cos x plus c. Again, for these results to be true, x must be measured in radians, and we'll see how that works down below in this example. So these will also be given in the formula sheet. You don't have to memorise them. But let's look at some examples. If we integrate 5 sin x plus 2 cos x, we integrate each bit individually. So the integral of sine is negative cos, so we're going to go to negative 5 cos x. And the integral of cos is sine, so that's going to be 2 sin x. Remember to add your plus c in. Okay, moving down. When you integrate here, we have got limits this time, so we need to substitute these in and then find a value for this. So first of things first, we integrate 4 cos x, which is going to go to 4, okay, we'll do that here, sorry. Integrate 4 cos, and that's going to go to 4 sin x. And sin is going to negative cos, so that's going to be take away 2 cos x between 0 and pi over 4. We'll now sub the top value into both x bits, x parts here, and then we'll do a takeaway and substitute in the 0 part. So 4 sin pi over 4, take away 2 cos pi over 4, close your brackets, and then take away 4 sin of 0, take away 2 cos of 0, close your brackets. It's really important you do this and remember to put the 0 in. Some people get so used to putting the 0 in when there's x's and it cancels all down to 0 that they forget to do this second part. Remember, when you're dealing with trig functions, then the sine of 0 is 0, but the cos of 0 is 1. So this will create a value here. Okay, so let's look at how to do this. Well, pi over 4, that's 180 divided by 4, which is 180 and then 90 and then 45. So that's 45 degrees. So sine of 45 degrees is 1 over root 2. So really what we have there is 4 times 1 over root 2. And the same here, 2 times 1 over root 2, because the cos of 45 is 1 over root 2 as well. Take away, the sine of 0 is 0 if you picture the sine wave, and cos of 0 is 1, so we've got a negative 2 there. But we're taking away negative 2. That's why I've put it in brackets here. So 4 times 1 over root 2, that's going to be 4 over root 2, take away 2 over root 2, and then add, because you're subtracting a negative 2. So we're nearly there. 4 over root 2 take away 2 over root 2 is just 2 over root 2, add 2. Now let's not leave a third in the bottom line, let's rationalise the denominator here. There's often a mark for doing that. Leaving it like this would lose you a mark in the final exam. So to rationalise the denominator, we take our 2 over root 2 and we multiply by root 2 in the top and the bottom. So we're really multiplying by 1 so as to not affect the value, but we get rid of the root in the bottom, because root 2 times root 2 is just 2, and we'll get a 2 root 2 in the top. These two will cancel because you're multiplying by 2 and dividing by 2, so that just cancels down basically to root 2. So we get root 2 plus 2, and that's your final answer here. Okay, final calculation up at the top here. We have to integrate 2 sin x between 0 and 4 this time. Now, we don't know the exact value of sine of 4, so we have to use radians. To do that, we need to use a calculator and turn it into radians mode. So let's integrate it first. If you integrate sine, you get negative cos, so that's going to be negative 2 cos x between 0 and 4. And then substitute the upper limit in first, take away, and then substitute the lower limit in. So this is what we're going to have here. Negative 2 cos 4. Then you're going to have a take away negative again, so that's going to be a plus. So take away negative 2 cos 0, so a plus 2 cos 0. Put these values into your calculator when you're in radians mode, and you'll get an answer of 3.3.